Okay, I started it.
Okay, fantastic. Thanks, Nancy. Welcome, everyone. My name's Travis Kinney. I'm a bridge engineer with David Evans and Associates. We'll start off with just some housekeeping here. This is just kind of a typical go-to meeting format. So you have the ability to unmute or to mute yourself. I see Nancy or Todd. I think I'll probably ask you to help folks mute themselves when they're inadvertently not muted. We're like, I don't know, we got a little over 50 folks in attendance, so it's probably okay to unmute and ask a question if you like to do it that way. If not, feel free to type it into the chat window and we'll do it that way. Jason and our NCPP folks, maybe you could help me with the chat window. It's 3 screens removed from me over here, so I won't be able to keep tabs on it. But maybe if we focus on having questions in the chat, then we can go ahead and do it that way. And you guys can just look for an opportune time to unmute and interrupt me. Okay, so my background. So I have about 16 years of experience, and it's largely in bridge maintenance, rehab, preservation, load rating, and program management. I do work for a consulting firm now, David Evans and Associates. But prior to that, I worked for ODOT as the bridge maintenance engineer. This presentation is really brought to you today by AASHTO TSP2 program, and more specifically, the local agency outreach working group. I've had the privilege of co-chairing that for a while now, and I do that with Jason Driver. Jason, you're on the line too, aren't you?
Yes, I am.
Man in the chat.
Okay, fantastic. Thanks, Jason. Okay, we have a lot to cover today. For each of these different topics you see on the screen here, I actually have given probably about a half-hour presentation on each of them. So if at any point throughout this kind of training today, you're like, wow, Travis, you really blew through that. I'm gonna need a little more details in order to actually implement what you showed me. Know that at the end of this training, I have links to previously recorded presentations by myself and other folks that have hit on all these topics that you can go ahead and watch. They're loaded to YouTube, so you can review them and kind of slow down a little bit and look at them that way. Just a little background. So TSP2, we're well, there's roadways and then there's bridge. I'm focused on the bridge side, but it's a bridge preservation group, and we're not trying to sell anything. There's no sales pitch going on here today. It's just trying to encourage folks to get the resources they need to do bridge preservation and maintenance in a timely manner, so that we're not always just replacing the very worst bridge or waiting for piles to look like this one here on the right, where you're like, okay, it's probably time to do repairs. I know that a lot of times we're stretched thin, and we personally and I myself feel that like preservation and timely maintenance is a good way to go ahead and get ahead of the curve at times. I'll say that, so I'm out of the Oregon, so my experience is largely based in the Pacific Northwest. We certainly have lots of timber bridges on both the state and local system. When I worked as ODOT's bridge maintenance engineer, and even now as a consultant, I've had a chance to work with and learn from some just absolutely stellar bridge crews. So this isn't necessarily all information I've gathered myself over the years. This is largely what I've been taught, and had that opportunity to work with those folks. Bridge maintenance has been dealing with timber bridges for decades. You know, you guys are really the front line of keeping those bridges in service. And so that's just what I'm sharing here, is what I've seen throughout my career. I know for sure that there are many more repair methods and preservation methods that are out there. Just because I don't show your method here doesn't mean that I dislike it. It just means that I probably didn't have it or didn't have time in this presentation. Almost always after I give one of these, I have someone come up and say, hey, you know, we like this system. And that's great. I appreciate that, because then I get to learn one more new system. So I'll give you my contact information at the end. If you're one of those folks that say, hey, we have this great strategy for repairing timber, by all means, please feel free to share that with me. Okay, so timber bridge inventory. I guess I should come clean now since I'm starting off with a graph. I'm an engineer, and so we love our graphs and charts. I promise this presentation has more pictures than graphs, but here I am on slide 3 and we have a graph. What you have along the bottom axis here is you have the year, and the vertical axis is the bridge counts. Red line is bridges in poor condition, yellow are bridges in fair, and green are bridges in poor. And so there's about 16,000 NBI bridges where they're listed in the database, the Federal Bridge database, as being timber as the main span material. So out of those 16,000 bridges, 14,000 of those are owned by local governments. So congratulations, local agencies, you own the lion's share of those timber bridges that remain in service. I think that's because a lot of the state DOTs have had maybe a little bit more funding for sustainable replacements, and timber bridges are usually a target. But I would say is this 16,000 bridge number is really low for what is actually out there. And that's because it has to be the main span, the primary material is timber, to fall into this category. It doesn't count all those bridges where you have steel girders sitting on top of timber pile abutments. It doesn't count all those bridges that have concrete spans that are being supported or concrete slabs that are being supported. So this is a pretty small number, but I think it kind of helps show on how important the timber bridges are for not just the country, but specifically for local agencies. The other thing that I would highlight from this graph is you can see the green, the good bridges, right? They're going, the number of those is dwindling as we're seeing the number of fair bridges rise significantly. We're also seeing the number of poor bridges increase. In fact, out of these bridge population, the timber bridges, it accounts for 10% of the poor condition bridges for local agencies. So it's kind of a disproportionate percentage. So that's partly why we care. Let's jump into, what are we looking at? So let's start with rot. That's probably the biggest driver for timber. And for rot to occur, you need several things to happen. You need a supply of oxygen, you need moisture, you need favorable temperatures, and then you need a food supply for that fungus. You need wood. And so if you take one of those away, you're actually not in a bad shape. The picture over here on the right of the picture of this slide is a retired bridge inspector from Oregon, and you can see that he's got a good personality there. But I swear, every time I get a picture from an inspector that has found something pretty bad on a bridge, they always look so excited. Like, look what I found, right? It's like their job is to find bad conditions out there. They also just generated like 2 weeks of work for maintenance. And so we're like, look a little more disappointed next time when you come in there. So anyway, it's just a funny picture. I like to kind of highlight that. Where are you going to find rot? So if you're looking for rot, you should be looking near the ground line. So, right, we need those conditions to be happening for rot to happen. The ground line's a good spot where it traps some moisture. You still have your oxygen and airflow. You're in direct contact with the ground. It's a good place to look for rot. You can see the picture on the left is some timber piles where it's already been kind of dug out in front of it. And they have some lines and paint marking on there to let you know where the rot is occurring. The other one is a sill plate for a timber post. And you can see that there's some paint on there as well where they've indicated a location where you have rot. Now, one thing to note is that as you get further into the ground, you should get deep enough where you've cut off the oxygen. And so usually at some point, you get out of the rot and the pile's protected again. Waterline is another good place to look for timber, or for rot and timber. And it's that wet, dry cycling that is typically a big driver for it. So that's a good place to look. If you have a tidal area, you might have some of those issues, or near a stream where you have the up and down of the flows, getting the pile wet and allowing it to dry. One thing I would note is that if you get all the way underwater and it stays underwater all the time, then you've taken away the oxygen component, and the timber piles actually perform quite well. So that's why divers aren't usually finding rot down deep into a stream. What they're finding is towards that water line where you can see it. One caveat is that although rot is protected in the water, if you're in salt water, marine borers can actually destroy piles pretty quick. So just something to kind of pay attention to. Again, we're not trying to cover every possible case, but these are the common ones that I come across. Overhangs and leaking joints tend to be great places for rot to build up, especially on our pile caps. So if you have leaking joints above those, or especially if you got vegetation growing on your caps, it's a pretty good sign that you got a great supply of moisture, you got oxygen, you got all the right stuff to be growing stuff, including fungus, and you'll get some rot there. So how do you find rot? So we kind of talked about a little bit where you look for it. And rot's hard to find. piles and timber members typically look really good until they've rotted almost completely out. And the reason for that is structural members are treated with preservatives, right? So when they go in, it's a pressure treating process where they incise the outside of the timber and they force this preservative treatment into the outer shell of the timber. They can't get all the way into the heartwood, and so what it does is it basically creates this ring of protection on the outside. And so typically these piles rot from the inside out. So this is a particularly, not a great pile that was been removed from service over here on the right in the photo, and you can see that the material on the inside is completely rotted out, and you are left with just basically a shell of timber around the outside, which makes inspection and finding these particularly challenging. So some of the methods that they use for finding the rot, here you have hammer sounding. I had done plenty of hammer sounding in my day. I will say that I'll highlight the second bullet here that it definitely does take some training in order to do it. I've had some inspectors swear by it needs to be a 3-pound hammer. And what you're doing is you're sounding hitting the member, and you're listening to the acoustics that come from it. What you're looking for is something that sounds hollow or kind of like a dull response, not that crisp timber that would indicate a solid wood. When you have smaller levels of rot, it becomes really hard to get it with hammer sounding. I don't know that I've ever been trained enough to really be able to find it, unless it's pretty bad, right? If you have a pretty significant rot on the inside, then you can usually be able to tell. Drilling. Drilling is definitely a more destructive method, but it's been around for quite a while, and there's been a constant pull between bridge maintenance and bridge inspectors for as long as I've been around, and for certainly before that, of them going out with the hammer method and the inspector saying, hey, this pile's rotted, repair it. And so they go out and they cut it out and they repair it, and then they come back and they say, hey, look, this pile looks great. So what I have always said is drill it before you pull anything out. Drill it as even a first course of inspection. And I'll get to a couple different drilling methods that are here, but this one is just using a 3/8 inch ship auger. You're just drilling into the member, and you're looking at what's coming out. If you have nice, clean shavings of timber that's solid, it's a good piece of member. If you have something that looks like this in here, where it's goo, or almost some of them look just like mud as they come out, then it's definitely rotted. I would say here we got an example with just their hand using it. You got a lot of chemicals in that wood from the preservative treatments that aren't usually very friendly. I would suggest wearing a glove. I would also suggest that as you're drilling these and you're trying to find the rot, right, you're leaving 3/8 inch holes behind, which if you didn't find rot means that you now have a nice avenue to the middle of the timber where it's not protected for rot to start occurring. So plugging the holes is critical. Maybe being a little bit cautious in how often you're drilling is also a good idea. And then if you find rot in one hole, and then you take that drill bit and you go immediately down, another 6 feet where it's not rotted, and drill again, you're actually spreading the mold or the spores down, and you can go ahead and cause more rot that way. So sterilizing the bit is a good idea as well. They also make fancy drills out there that cause much less damage, where it's a very fine bit. Then they actually give you a reading of what you see in the wood. And so on the left is an inspector holding one of these, what they call resistographs, and it actually measures the resistance as the drill bit is auto-fed in. And then it gives you can get like a readout or a printout is what's shown here on the right. And so, yeah, hopefully you guys can see that picture okay. I tried to make it as big as I could, but you can see all the spikes on the left-hand side of the picture, and then you kind of flatline through it, and then you get the spikes again over on the right-hand side. Well, the spikes are as you're going through the grain of the material, so it kind of gets this big push up in resistance and then drop as it keeps going. Those are great. If you're getting spikes up and down, you got good solid wood. And then when it flatlines there, it means it's just not really meeting any resistance anymore as it's advancing. And so it'll give you that decay section. And so it's a really cool tool to be able to look at it. The holes that are made from it are so tiny that they're considered like a non-destructive method. And they make a bunch of different varieties of those. There's super fancy ones that have Bluetooth and report back out to a tablet on the readings. There's ones that actually sketch out this on paper, which is what's shown on this picture on the right. Then they have manual ones that have like a feed tube that I didn't get into this presentation, but are basically a handheld, and you feel it and look at a gauge as it goes through. There are different options for looking and see where that rot is. So once you find the rot, right, you have some opportunities for preservation. So I'm going to run through a few slides of preservation before we get into the repair. This one here is fumigation, right? So when the timber is originally installed, it has that preservative treatment around the outside. That works great, especially if you're going to replace these bridges on a normal time cycle. But a lot of these bridges are well over 50 years old. So if you're going to hammer timber into the ground or leave it exposed to weather, it's just going to rot. That original treatment is not going to hold up over time. And so fumigation is one of the options that can be done to extend the life of it. This one that I'm showing here is a mica-fume, and it goes into the timber and it turns into a gas and spreads out throughout the member, both vertically and horizontally. It's I don't know. So it's hazardous material, right? So it's a pesticide that goes in there. It is you can see kind of the label there. You know, it's a high acute toxicity. So with the treatment, the more hazardous the material, the better it is for protecting the timber, but also the harder it is to use, right? Like a lot of times you have environmental restrictions. I would say for this one that it does require a certification for use. You have to be trained in how to handle this material properly and have a certification to show that you're able to do it safely. But it is definitely an option that's out there. I know some bridge crews that have taken the training and use this on a regular basis to help extend the life of the members. But basically you're drilling a hole into the interior of the member, and then you're applying this material into the inside of it where it can go ahead and protect that heartwood. Another option for preservation are borate rods. These ones are widely used and commercially available. A lot of times they're in the log home industry. Railroads and utility companies have been using these for quite a while. I actually learned about this from Washington State, who is starting to use it as well. And I know that there's been some presentations on this, and they'll be at the links that I'll show at the end of the training where it's been used much more in depth of what it is. But essentially there's these little glass rods, it's a solid form that go in. When the wood reaches 25% moisture content, it starts to dissolve. And as it dissolves, it spreads out that borate into the timber, which helps prevent or protect the wood from insects and fungus. The manufacturers, a bunch of different manufacturers for these, and they'll give you guidelines of at this spacing for this size of member or this size of rod, and then you just go ahead and plug the hole. You can kind of see a wood dowel over on the right-hand side of that picture where they plugged it at the end. Just to cap it off, right? You want to get the preservative on the inside of the wood, but you don't want to leave that hole for moisture and insects to get right into the heartwood too. I would say check regulatory requirements. My own personal experience with this is that I haven't had any pushback as long as I keep this above ordinary high water. I would not install it down below that mark because one, when the stream comes up, you're going to lose all that borate anyways, and then two, I just don't want to. I never got anyone on the regulatory side to say that it was okay to install it below water level. And maybe the easiest option is just protect the wood from the moisture in the first place, right? So I showed that cap earlier on in the training where we had that grass and dirt and debris growing on top of those caps on the overhang. Putting something simple like flashing over the top of it could protect it. It's a good option. Here's an example where there was a timber pile that was exposed and you have that end grain just right exposed to the weather. So they put metal flashing over the top of it to help seal it up. Other options for preservation are maintaining those joints that are above our caps that leak all the water down below and onto the substructure, right? That can go a long ways into extending not just the timber substructure members, but also the girders that are sitting on top of them as well. And then installing waterproofing membranes can help seal up the decks as well, especially if you have like a timber deck. Waterproofing membranes are a good option to help extend the life of those so that they don't get so wet in the first place. So I think that takes us through all of our rot preservation methods there. I'm going to start running into some other common issues that happen with wood. You got cracks and splits as well. Picture on the left is a timber girder that had a big crack with it. Crack goes through the grain. It kind of starts at the bottom and works its way up into the member. That one you could actually see move a little bit underneath traffic. So it was a pretty bad situation. Splits are going more along the grain, but go all the way through the member. And then you could have crushing as well, start to come through as well. So here's kind of highlighting that crack if you can't see it super well. And then here's the crushing that you can see. So when should you do something, right? The preservation should happen as soon as you can, right? Like even installing the borate rods in a member that's not rotted already could extend the life of it. If you have just a little bit of rot, it might help slow it down or stop it. But when you need to take like corrective action beyond preservation, it really depends on what's damaged with it. If you have rot, it really depends on the member. So if you have a pile, a lot of piles still have an awful lot of capacity, even at a 3-inch shell or 2-inch shell on it. It's probably at that point where most people would say, hey, you really should repair this. But they tend to fare a little bit better from a capacity standpoint. Caps and beams, in my experience, with not too much rot, they can start to become load critical pretty quick. You can start getting load postings triggered from them. So it's kind of tough to say when do you have to do something. If you have load raters that you work with, I'd suggest checking in with them when you start to get significant levels of rot and put it on their radar and see if it's time to do a repair. We'll go through a bunch of different repair options for rotted members. Cracks, splits, and crushing. So those are all signs that something has been likely overloaded. So that should be a pretty good indication to us that if we're getting damage from load, we should be looking at what caused it, and it should probably trigger an immediate repair, shoring a restriction. I would again reach out to load raters or whatever maintenance folks you have on staff and have them do an evaluation if you're not sure of what should be done. But I really do blame these new fleet of trucks that are going across the country for disproportionately taking out timber bridges or causing some of these crack splits and crushing. So if you have a long span bridge, like a lot of our steel and concrete span bridges, then these trucks, even though that they're really heavy in a short distance, it's not the end of the world. It can spread the load out. But when you get these trucks on timber structures, which are typically shorter span, then something that used to be spread out over a lot of axles and a long distance at 80,000 pounds can actually get the whole weight right in your span now. And I think they're disproportionately picking on our timber structures. So I don't have anything more than anecdotal information on this, but I feel like I've seen more cracks in timber girders since these trucks have become more prevalent. And you probably have seen a lot of posting signs for them as well, and probably noticed a lot of those are targeting your timber bridges. Okay, so what do you do, right? We're gonna run through a bunch of different repair options here. So pile repairs will be the first one. There's lots of different ways to repair piles. They're probably the most prevalent timber member kind of across the country, right? Because a lot of times you have timber piles, but you have other things installed on top of it, like concrete, steel. Okay, so this is one option. You can do an FRP pile wrap. You can do epoxy injection into some of the voids. And here's an example of what that might look like. There's lots of different manufacturers out here that specialize in wrapped products. There's a lot of them can provide you some engineering guidance along with it. Some of the benefits to this kind of repair is that the original pile stays in place, right? So there shouldn't be any need for shoring as you do this repair. You're not cutting anything out and changing the structural path. Kind of the image on the left, and I'll give the reference to Pile Medic on that one of, they're showing it being installed underwater. And so you might be able to install these in water. There's lots of flexibility. It's not a preferred repair method for me, just because of the crews I've worked with, it wasn't their preferred method. One thing I would say is as you do these repairs, the ability to inspect the timber on the inside becomes lessened. I've seen cases where you want to include reinforcing steel and a bigger kind of a concrete or grouted annulus between the timber and the fiberglass jacket so that you get more of a structural repair out of it. But they're definitely an option that's out there. Helper piles. If you have a timber pile that's not in good shape anymore, you can do a helper pile. And this is an example from a maintenance crew out here in Oregon. where they got a pretty good system here where they go ahead and jack a new pile in next to the original pile. So this is also nice because you're not removing the original timber pile, so you're not having to shore the bridge while that pile gets pulled out. You're not having to do a splice down or in the water line, and so it's very useful, definitely when you're near water or in water. The challenge with this is getting enough load. So what you can kind of see here, and I'll run through a few slides of what it looks like for this one, but they're using a jack that's bearing up against the timber cap above it. And so it's basically using the weight of the bridge to push this pile down and get it into place. The problem is that the pile that was there originally, it's holding up not just the bridge weight, but it's also holding up traffic plus the bridge weight. And so something that you might have to do with these piles I've seen is they'll actually park a loaded truck on top of this location, so you get that extra kind of resistance to be able to use as you push that new pile down into the ground further. Other times I've seen where you've used two piles to replace one. So if you only have the weight of the bridge plus some amount, then you'll use two, right? So I push it with the weight of the bridge plus whatever other loads I have on top. You add up two of those and it probably meets your design loads. Depending on your inspection staff though, I would check on this because since you're not actually taking the original pile out, it's still there and they're still going to inventory it and they may just still mark it as a temporary repair. And that gets into the whole program side of things, right? Sometimes having a temporary repair is good if you're trying to replace a bridge, and sometimes it's not. So just something to be aware of. So one of the other issues with jacking piles is that you jack and you have whatever your throw of your jack is. Well, your throw of your jack is measured in inches and the depth of pile that you're going to do is feet, right? And so you jack, shim, jack, shim, jack, shim. And so this has this custom sleeve that was built here with those holes drilled in it for a pin to go through. And what they do is they slide that inside their new pile, and that just helps them with that sequence of jack, shim, jack, shim, jack, shim, so that they can get it installed quicker. The other item with this that I would highlight is that you're going to have to splice. You're going to probably have to splice at least a few times as you do this because you want to get that new helper pile buried as deep as you can into the ground to get your resistance and then also to keep it from washing out or scouring under. And so you get some welding in practice. And so here they are making a welded splice as they jack that first segment on the left there down far enough they're not shimming anymore. They say, okay, let's splice it and then we'll start the process over again. So getting a good weld on that. And then here we go, push, block, repeat, right? That's the system. You just keep doing it over and over. Unlike pile driving, you don't have quite as much control over the pile where you can have leads on it. So paying attention to what you're doing here and making sure you keep the pile straight is important. And then here they are just kind of blocking and redoing it again. You can see that sleeve on the left kind of in action here as they're keep going through the jacking process. So it takes a little bit of time, but again, you can do it in water with minimal environmental disturbance. You don't have to shore the bridge while you're doing it. So there's some real advantages to this kind of a helper pile installation. Some other kind of repairs I've seen is a banding repair. I would consider this a temporary repair. When these timber piles fail, you got the rotted inside core, and then you start to get that thin wall on the outside. And so usually how they fail is they'll mushroom out under load and kind of explode like I showed on that pile on the left. And so the point of these sleeves is to basically prevent that as your failure mode. Helps provide additional confinement to whatever timber's remaining. It doesn't necessarily drive up the axial capacity from a calc standpoint because you'd still have basically whatever remaining good section you have, but it's pretty easy to install. So this is a fairly nice banding system where they split some steel piles up and then welded some tabs to it so they could basically make 4 pieces and clamp it on to help confine it. And it's just another tool in the toolbox as you try and extend the life of these bridges. But again, on this one, I would likely consider it a temporary repair. Let's see, Jason, I'll stop just real quick. How are we doing? We got any questions that we should run through?
Just one question in the chat right now, and it's talking about distinguishing typical checking from splits and when does checking become a concern?
Depends on what is checking. So checking is when it's on one face, and a split is when it's worked its way all the way through the member. If I have splits that's like right through the middle height of the member, I'm starting to get worried that that's being load induced, because that's the highest kind of shear loading that it will see, and it'll start to actually split your member apart. If I have a check and a pile, it doesn't really get me very excited. Even a split in a pile, I would want to see where the split came from, but it may not get me as excited either because of how the load gets distributed in them. Okay, encapsulation. So here you can see this was a 5-pile bent, and every other pile rotted out on it, it appears. And so what they did is they basically used these steel corrugated tubing or seal lot with sono tubes, where they go ahead and basically encapsulate the pile full height. And so there's no longer, their timber pile is still in the middle of that, but they basically have made a new structural system around it to take the load. I personally haven't done the full height repairs on these. I know that there's a lot of states that use this as their go-to method. It's a lot of concrete and a lot of work to put them in. And with the crews that I've worked with, they just have found some options that they thought were maybe a little more efficient for them. My only other caveat with these ones is that if you live in a seismic region where there's any real concern for seismic, and let's just start with, these bridges were never designed for seismic, at least the vast majority of them. But if they still could be exposed to an earthquake, these new piles or these encapsulated piles are way stiffer than everything else on the bridge. And so you're going to try and lock in a lot of load that maybe you weren't intending to as you happen. And again, seismic is probably not the driving design concern for these bridges. Okay, so pile splicing. So another option is you just cut the rotted section out, splice your new member onto it, and then go ahead and build off of that. And so over on the left, I have a picture of some members that this bridge has had some erosion issues. And so you could see that those concrete splices probably were done at ground line when they were done. And then as it eroded, they're now being fully exposed. But that's basically just making a reinforced steel concrete collar that goes around your still good original pile below, and then ties in and couples into a new pile that's above it. So these ones look like they're timber, but I've certainly seen details where it's steel pile above. And it's a very common detail that I've seen, but it's basically you're splicing onto the new member. So at some point in the repair process, you have cut the pile off, and that's where you need to think about, like, what shoring did you need? And the shoring starts to become the driver on how much effort it is for these repairs. Over on the right-hand side are a slightly more compact steel splice setup. And so on the bottom of both of those, you see a steel round pipe pile, and that's actually over the top of a timber pile that's getting grouted together. And then you have a new steel pile on top of it that's repairing the rotted segment. On that one, all the way on the right, you actually have it's like I call it a dumbbell repair, where you're just removing a segment of the timber pile, and the top part is actually being spliced as well. So you have two splices to make that one work. And that would have been an example of a bridge where the piles were probably really long, very tall vents, and there was concerns with the amount of effort and bracing that would have to be ripped out in order to actually do a full height. Typically, full height is the way to go. Here's a little bit more details on that splice repair. And so ODOT has actually developed a standard detail for this that's available on their website. It has some information. A standard detail is different from a drawing in the sense that this is not stamped, so it would require a journey evaluation to use, but it goes through and shows all the different details that kind of go with that. Over on the right-hand side is a kind of a cross section of what that repair looks like. So again, you have that steel or the original timber pile down below, and then you have that section that rotted above it that has been kind of, all the rot's been augured out. You have a new steel can that goes over at the top, and then you kind of encase it all together and then make a new steel pile above. Again, I've given an entire 30-minute presentations on this, and I'll show it later. I'm going to go through a few slides to give you a little bit more idea of what this looks like. But I recognize that probably could spend more time on it. The idea with these repairs, if you're going to splice onto the original timber, is hopefully you get your new repair at least 2 feet below ground line. We shoot for 2 feet because it helps limit the chance that you're going to reinitiate rot down below this pile and have it rot out right below your repair. You always want to get all the rotted material out. We did some destructive testing with Oregon State University on these repairs. And part of the idea was, do I have to dig until I get to 100% solid wood? Or can I use that 2-inch shell or so and kind of fill in the cavity with concrete? And the destructive testing gave us confidence to be able to do kind of like a, I guess I've heard it referred to as like the cavity repair, where you fill the cavity as part of the work, and it just helps limit the amount of excavation you have to do. Here they are, they've cut the pile off, they've augured the rod out of the inside, and they have that steel can now sitting over the top of the original timber pile. And they're installing some borate rods into it to help, kind of help keep that rot from reinitiating below it. And then what you're gonna do is you're gonna grout the two together. So now you've completely encased the timber in grout and steel, and then you weld the steel cover plate onto it. And so basically what you're doing is you're building a steel cap or cover encasement on top of your original timber pile. And now that you have steel there, you can weld to it, right? And so now you can make that nice moment connection to the pile so it can handle bending. And then the sky's the limit for what you guys want to come up with from there. One thing I would note with these is that the ones I've been involved with, we have a detail where we go ahead and reload the pile, right? And so you have, during this repair process, you've taken all the load out of this pile and you want to put the weight of the bridge back into it. And so you can just use a little jack here, and with some calculations, engineers should be able to tell you, load it to 1500 PSI, and that's the weight of the bridge. You actually get that load back into where it belongs as part of that pile repair. Once you've loaded the pile and you have your new steel piece in above it, then you got to kind of close that gap up. And so here's some channel shims that are being used or cut to fit and then welded in place. Kind of get the jack loaded and disconnected from your hydraulic fluid, and then start welding it up enough to hold the load. Get your jack out so you don't have to buy a new jack each time, right? Get it set up, get the jack out, and then go ahead and weld that all the way up. The example in the middle there, you can see they're doing that splice down at the bottom of the repair, and then on the left-hand side, and then I think that's the completed section on the right, they're making that last splice up at the top. I see a huge steel plate on the repair on the right at the kind of where it interfaces with the concrete deck or a concrete slab above it, and that's just because the original timber stuck all the way up through it, and so they would have cut it off flush with the concrete to make that happen. Okay, beams, right? We have, other than just piles, we have beams issues, and so we got jump stringers. And so when you have a beam that has rotted out on you or has cracked or split and you have an issue, you can do these jump stringers, and it's basically installing new stringers right next to it. I would caution that bigger is not better here. And so what you're trying to do is you're trying to match the capacity of the member that has failed, but you don't want it to be so strong and stiff, it's really stiffness that you're looking at, that it's trying to take all the load, right? And so if it's a lot stronger or a lot stiffer than the beam next to it, then when the trucks drive across, it's going to try and hold up a lot harder than the timber beam next to it, which can actually create damage in your deck. One of the issues with these is it's really easy to draw on paper. Again, speaking from the engineer perspective, they're really hard to get in place in the field, right? And so assuming you're not just ripping the superstructure off and rebuilding it, you're trying to feed this beam up into the deck area or up into its hole to replace that damaged timber beam. And so what this usually involves is you're knocking out the diaphragms that were there. And so you can kind of see there was timber blocking here, and there's a concrete diaphragm at midspan that's now missing on this segment. And then you're trying to get the beam up tight to the deck, and so then you're starting to shim underneath those jump stringers in order to get them up tight so they actually are taking any load. It's just a lot. It's a lot. It's challenging. There's some times where you don't have any real choice and that other repair options aren't on the table. I do want to run through a few other repair options. So this is a beam repair when you have a crack. And so this was a drawing that was produced in Oregon and has been in service for quite a while. If you get a crack that initiates there, it's called what we call the fish plate repair, where you go ahead and you put a steel plate along the bottom, and then you run lag bolts up through that to kind of bring the beam back together. This is what it looks like in practice. So you can see the lag bolts running up the member and then that steel plate along the bottom. I will say that it has a great service record. I see a lot of these repairs in the field as part of the inspection and just seeing inventory. I personally haven't been able to run through the calcs on it and get them to quite work. The weak link is the lag bolt on these. But again, that's a repair that's out there that I see. Another option is, instead of, if you have like a split that goes through the member, is to do these side plates to it. And so instead of lag bolting through the bottom and trying to stitch it back together, you go ahead and put plates on either side of it and bolt it through. And so this is looking at a section where you had a girder split that was running down the member, and then these plates that would run and be installed across it. There's a cross section of the same kind of repair where you're actually bolting through to the plate that's on the other side, and then you got that crack that's sandwiched in the middle. Here's just an example of what it looks like actually in the field. You can see all the bolts aren't installed on this one yet. They're in the process of installing it, but you're basically stitching across that crack and using the steel to help tie the member back together. Okay, cap repairs, and this actually could apply for a beam as well. You can do what's called an encapsulation, where you build basically a steel cap around the existing timber cap. I've seen lots of different variations in how this has been done. One of the things I would highlight on this one is you can see that there's a steel plate that's just between the timber pile that extends out to the channels that are sandwiched on either side of it. And the intent of that is to actually, so that you can keep the pile from punching up into the rotted timber cap that's below it. Depending on the details for this, this one here, it was intended to be more of a temporary repair, I believe, because it doesn't actually replace or make a connection directly to the superstructure above it. So it's not actually taking the load directly from the girders or the slabs that's up above. They still have to work their way through all the timber to get to it, and then from the timber cap into the channels, and then from the channels down to that steel plate into the pile. So it's a unique load path, but it certainly provides a lot more capacity than what was there before. There's another option that's out there that I've done where you're actually making a fixed connection to the pile, and this one's very similar to the one that I had shown before, with the exception that these channels are installed, and this looks a lot like the previous one. This was smaller segments. There's some utility conflicts that wouldn't allow a big channel to go in. So these were like 6 feet, I think, in length, and they're snugged up tight up against the cap. So they're taking that load there. But right now, how it's shown, I have the load coming from the slabs into the channels, but then the channels aren't making a direct connection to the pile. So I haven't actually replaced the original timber cap. I've just kind of helped reinforce it. This is kind of an example on this slide that shows what it could look like for you to go ahead and make that a positive connection with the channel or with the pile below. So straight from the channels to the pile. You can see here they're actually cutting the top of the piles off, so that timber cap is no longer in the load path at all. And then there's kind of like a timber pile repair. There's a concrete collar, that's that steel encasement going around the pile to make that fixed, and then channels, shims that are welded to the channel that's on the cap up above. And so now you've completely replaced the load path from the timber. So this was an in-place repair that was done. And of course, you could just rip the cap out, right? You don't have to keep the cap in service. You can take the timber cap out and replace it completely. You can put in a new timber cap, or you can put in a steel cap. Steel caps I seem to think are more prevalent. And then usually the trick with that is you size the steel H-beam there to just fit the size that was original timber. So usually your new cap has a tremendous amount of capacity compared to the timber it replaced, just because you're just fitting the hole, right? You're just matching the original timber size. The big issue with this now comes in how do you hold the bridge up while you rip out the timber cap and put in the new steel cap. So the actual repair is easy. Getting the repair in place can be a tremendous amount of work. So I got a couple slides here showing some systems that have been done. You can do shoring from the ground to lift the bridge up and get your old cap out and the new one in. This is the shoring system I've seen throughout the Northwest, and I've seen different variations of it where it clamps onto the timber pile below the cap that's being changed or replaced, and gives you that new kind of wings to jack from. It gives you the new supports to lift the bridge off of the cap and pull it in and pull it out. So you're getting that load back into the original timber pile. This is particularly helpful if you're over water, right? It's really hard to jack from the ground if you're in the water, or if you're in other locations where it's just going to be really hard to reach the ground and jack from there. Here's a side view, kind of a section of what that looks like. So there you have that pile clamp with those steel wings coming off of it. And then those two arrows that are pointing down, those are a false caps. So they're what's taking the load in the short term while we're trying to pull that cap that's in the middle out. So they have the new cap all sandwiched up next to it that they're trying to replace. They have all the weight of the bridge onto those pile clamps. So it's lifted up. There's actually a separation between that original cap and the bridge. And then they just use a come along and pull one cap out with the new one. So there on the left is, getting ready. You're all ready for the replacement. And then over on the right, there you've slid the new cap into place. The old cap is now off to the side. That was all rotted. And then you can let everything back down and make all your connections back up. I glossed over that in one slide. I have a whole presentation on it. It's quite a bit of work to do. The photos that I got from here was from one of the Oregon bridge crews that was really pretty good at this. They had lots of timber in their area. So that was a lot of different repair kind of options. And like I said, this isn't the only repair option. There's lots of different methods that are out there. But after we kind of went through and looked at what the repairs look like, I wanted to flash back real quick and be like, doesn't preservation seem like a pretty easy option, right? Here's the one worker. He didn't have a lot of clearance on that photo on the left, so it does suck that he's having to lay on their back as they're drilling that hole for the borate rods to go in. But it certainly is a lot less work than jacking the bridge up or bolting channels to it. And there they are, just drilling a hole and then tapping the rod in and then putting the plug in behind it. So that's kind of the desire of this partnership, is to kind of help highlight these areas where maybe it could be a little easier. Where do I get more information? Where do you see the rest of what's happening here? tsp2.org is the website that kind of houses all of this content for the Bridge Preservation Partnership. That image over on the left side of this screen is what you get to when you type in tsp2.org. There's a pavement preservation side, and I know local agencies usually wear a bunch of hats. So you may care about pavements in addition to bridge. There's a whole different side to this partnership that's all pavement related. I click on the bridge side because I don't do anything with pavements. So if you click over on the bridge side, then it'll bring you to that bridge link that you see there on the right. So click that button there, and then over in that ribbon, you'll see there's this library option, and you can click down onto video presentations. I think there's a hot link somewhere else on that page too, trying to make it easy, but I'll just kind of pop that up again. And then today's presentation's being recorded, and that'll file underneath the local agency button here, but there's just a ton of content that's on this website, all free. And you'll see that there's an option here for timber, and so that bottom right, timber structures. And if you click on that one, it'll bring you to this list here, where you can see a bunch of different timber repairs that have been done. You can see who presented on it. Usually there's a PDF that shows the slides for it. And then there's a video. It shows the video of the person giving the presentation. And so it's a good resource that's there. Again, it's just available to try and help folks out. I will put in a plug for the partnership. We're having our national meeting this year, and it's in Salt Lake City, Utah. It's a great kind of dynamic of local agencies, state agencies, federal highways, manufacturers. There's usually some contractors, there's consultants, there's just about anybody that has to do with bridge preservation shows up at these things, and it's a good information exchange. It's September 9th through the 13th in Salt Lake City. And if you're really serious and interested but are struggling with how to get there, a lot of times the partnership offers grants. So if you're interested and have a desire, I got my contact information on this next site. Shoot me an email, and I can get you to the right people to maybe get you in touch with, seeing if there's any opportunities to help you get there. If you got budget and are interested, I strongly encourage you to go. There's live demonstrations and just all kinds of great stuff to learn at those. And the benefit from having more local agencies attend is we also get to learn more from you as well, right? It's not just a one-way street. We love to engage and see what you're experiencing, what you know. Like I said, I certainly have a perspective on a lot of this, but I don't have all the answers, and I'd love to chat with you. So with there, I'll kick it over to questions. QR code over on the right that just takes you, in case you can't remember, tsp2.org, just takes you to the website there. Okay, I'm gonna go look this way. I can see the chat window. Nancy, do you want to talk about the rebranded TSP2?
I can talk just briefly. I just wanted to mention it. AASHTO rebranded TSP2 to Preservation Management Technical Services Program. It's just will probably always be TSP2 to many people, but they've just asked us to keep reminding people that is same program, just rebranded. They rebranded all their technical services programs.
Okay, thank you. Matthew, you wrote a good question in here about, hey, doesn't a lot of these repair methods give you opportunities to trap water again? Does this not create you an opportunity or an issue in the future? I will say that I have repaired people's repairs, and I have repaired the same bridge many times, usually in different spots. It is a very valid comment, especially with that one pile repair I showed where it actually cupped upwards to splice back into the timber. That one I really didn't like. Because it does create a pool to collect the water. It's something to think about in what you're doing. The other comment I have is trying to think about, like, how long are we going to keep these timber bridges in service? So, like, I like preservation as a means of delaying the repairs, and I like the repairs to last longer than the bridge, but holy cow, at some point we got to get funding to replace some of these things. These timber bridges from the 50s were not intended to be in service anymore, and I keep hoping for that big funding package to come through and actually replace some of these bad boys. Will the slide deck be available on TSP2? I think we can absolutely make that happen. Just where the slide is. Okay, I think that was all of them. If anyone else has anything, feel free to unmute. Otherwise, thanks for being on today.
I wanted to just say thank you to Travis for the overview of the national meeting. I think that he probably did a much better job of explaining it and talking about it than I would have. So thank you, Travis. I did just want to note that there will be 2 full sessions on just really focusing in on local agency presentations, challenges, and so I'm really happy to have that. I will make one other note, just for those of you that were not aware, we were looking for a bridge preservation engineer to another one to join us at NCPP. We have hired Stuart Lenz. He is on the call. He has retired from Arkansas DOT, was in there doing. I'll let him tell you if he wants to expound more, but we just want to let you all know where it is here, and we are very excited to have him.
Thank you, Nancy, on that. Like I said, I was in design for about 28 years at Arkansas, and then moved to maintenance for the last 7 years of my career, where we were responsible for asset management, inspection, maintenance, actually oversaw repair crews, and developed kind of a maintenance and preservation and repair plans for most of the state on that. So with that, I do want to, I'm glad to be here, and hopefully I'll be an asset or able to help all there. And I want to just commend Travis, is that every time I hear one of his talks about timber bridges, is that I'm just, he does an excellent job on it. I know that from other conferences and other things that he's done, I would take those back to Arkansas at my job and either modify or use them as he had them, or modify them slightly to meet our equipment and our goals and needs and whatever else. But Travis, I commend you for excellent job on that.
Thanks, Stuart. Okay, we're right at our time here. In 2 months, we'll have this meeting again. If you're interested in being on the, getting the invite directly from me, shoot me your email address in the chat window. If you have a topic you'd like to have presented on, it's a great opportunity to just go ahead and type in the chat window what it is, and we can find someone that can answer it. I may not be the expert, or Jason might not be, but I bet you know somebody. I always think that the partnership and these kind of things are great opportunities to have someone else do your work for you. So if you have something you're like, man, I just don't know what to do with this population of bridges, it's driving me nuts, throw it in there and see if we can't get you an answer. So with that, I'm going to go ahead and say thank you, everyone, and we'll go ahead and turn off the recording.